Have you ever come across a pressure regulator encased in ice? Well, that is a consequence of the Joule-Thomson effect. The Joule-Thomson effect, also known as the Joule-Kelvin effect, describes the phenomenon where the temperature of the gas changes when it is forced through a valve while kept insulated so that no heat exchange occurs with the surroundings. This effect is often found in pressure regulators. In pressure regulators, gases are typically passed through a narrow orifice or a valve. When the gas then expands through the regulator, its temperature can either increase or decrease depending on the initial temperature and pressure of the gas, as well as the specific characteristics of the gas itself. Most gases typically decrease in temperature as it expands. Apart from hydrogen and helium, they heat up. The same phenomenon as when you can spray a deodorant can and it gets cold in your hand. In pressure regulators, understanding the Joule-Thomson effect is crucial for maintaining a stable operating conditions and controlling the temperature of the gas as it passes through the regulator. By manipulating the pressure and temperature relationship, utilizing our heated regulators, pressure regulators can ensure that the gas leaving the regulator meets the desired specifications for pressure and temperature. The Joule-Thomson effect is a key factor in ensuring the correct components are put into the regulator. Pictured here is an LFI40 that is being used to reduce CO2 pressure. As the gas expands, the regulators become so cold and frozen the moisture in the air around it. This can be concerning for customers, but in this instance, the regulator worked perfectly for 3 weeks, cycling 500,000 times without any problems. If you'd like some assistance in the Joule-Thomson effect and how we can correctly size a regulator for your application, then please feel free to contact Pressure Tech.